Magandang buhay! Please allow me to share with you a lecture about crystalline structure. Now, this lesson aims to have a lecture on how to identify crystals and amorphous solids, discuss the difference between crystalline and amorphous solids, explain the features of the basic unit cells, and finally, describe the unit cell cubic structures. Now, let's discuss the difference between crystals and amorphous solids. Now, crystalline solids have regular ordered array of components held together by uniform intermolecular forces. No? So, yung arrangement ng mga particles sa solids ay regular and orderly. No? Samantalang yung amorphous solids are not arranged in regular arrays. Now, generally, the particles that compose a solid material, whether ionic, molecular, covalent, or metallic, are held in place by strong attractive forces between them. So because of that strong force of attraction, the particles of solids are in place sa space or sa mga positions nila. And therefore, these fixed positions of these particles, whether atoms, molecules, or ions of solids, are more considered. They are essentially considered this fixed arrangement in space rather than the motion of the particles. Dahil fixed nga ang kanilang position in space, rigid. So yung fixed position na yon ang kinoconsider sa pag-aaral rather than the motion, which is more important naman if we discuss liquids and gases. Okay? So again, crystals have regular ordered arrays of components, whereas amorphous solids are not arranged in regular arrays. Okay? Now, the constituents of a solid can be arranged in two general ways. So dahil diniscuss na natin na ang solid pwedeng crystals, pwedeng amorphous. So generally, the arrangement would also fall into general ways. If they can form a regular repeating three-dimensional structure called a crystal lattice, they can produce a crystalline solid. Now, if the constituents of a solid can aggregate with no particular order, so random, in which case they form an amorphous solid. Okay? Kasi sinabi natin kanina, yung crystals, fixed kasi yung mga particles nun in space. Samantalang yung amorphous, hindi. So, if the particles of a solid can aggregate with no particular order, amorphous solid ang mabubuo naman. If they can form a regular repeating three-dimensional structure, crystalline solid ang mabubuo or crystals. Okay? So, tandaan, pag may pattern, pag may order, crystals yon. Pag random o walang order, amorphous yon. Okay, so I have here some pictures of crystals and amorphous solids. Okay, so this is lead sulfide. Okay, this one is iron sulfide. Pareho silang may the faces of the crystals. Ano ba yung faces? Yun yung pinaka-plane. Can intersect at right angles. So yung dalawa right angles. Ito naman quartz, hindi right angle, Okay? Samantalang ito, volcanic glass na to, is an amorphous solid, Now, crystals have distinctive internal structures that in turn lead to distinctive flat surfaces or faces. So yung plane na bumubuo sa crystals, ang tawag sa kanya ay faces. The faces intersect at angles that are characteristic of the substance. Okay? So, nature ng mga substance, yung angles of intersection of the faces. Now, when exposed to X-rays, Each structure also produces a distinctive pattern that can be used to identify the material. Dahil nga nature yun, ano? Nature ng substance. Therefore, that property can be used to identify the crystals. Now, note that since the angle depends on the nature, no? It does not depend on the size of the crystal. Kaya maliit, kaya malaki yung crystals, the characteristic angles, no, yung intersection of angles between the faces do not depend on the size of the crystal. No? They reflect the regular repeating arrangement of the component atoms, molecules, or ions in space. Now, when an ionic crystal is cleaved, repulsive interactions cause it to break along fixed planes to produce new faces that intersect at the same angles as those in the original crystal. Okay? Now, in a covalent solid, such as a cut diamond, the angles at which the faces meet are also not arbitrary, but are determined by the arrangement of the carbon atoms in the crystal. Okay? So, ganito yung itsura niya, no? So, how do we cleave, no? A crystal, no? So, we have here cleaving of a crystal of an ionic compound along a plane of ions, no? Now, the formation of the ionic crystal causes one plane of atoms to slide along another. So, ito yun, no? Yan. Dito magki-cleave. Dito sa plane na to magki-cleave. Bakit nagkaganyan? Kasi pareho sila ng charge, no? So, 1, 1, and 2, 2. So, what happens? They would repel, no? They would repel. So, if you apply here a stress here and a little stress here, therefore, repulsion will be in effect. Okay? The resulting repulsive interaction between ions with like charges cause the layers to separate. No? But pareho pa rin yung nature. No? So, ganun pa rin yung itsura. No? Nagkahiwalay nga lang. Now, crystals tend to have relatively sharp, well-defined melting points. Why? Because all the component atoms, molecule, or ions are of the same distance, no? From the same number and type of neighbors. Kasi di ba nga, very ordered sila. No? So, very sharp at well-defined yung kanilang melting point. No? Now, the regularity of the crystal lattice creates local environments that are the same. No? Pareho-pareho yung itsura sa neighborhood. Thus, the intermolecular forces holding the solid together are uniform, and the same amount of thermal energy is needed to break every interaction simultaneously. Dahil nga very ordered sila, same distance, same orientation, so same lahat. So yung intermolecular forces holding these particles are uniform. And therefore, since uniform yun, you need the same amount of thermal energy to break those forces, intermolecular forces. No? Now, what about amorphous solids? No? They have two characteristic properties. One, when cleaved or broken, they produce fragments with irregular, often curved surfaces. And two, they have poorly defined patterns when exposed to X-rays, very unlike crystals, di ba? Because their components are not arranged in a regular array. So, yun. So, when cleaved, they produce fragments with irregular, often curved surfaces, unlike crystals, exactly the same as the original, no? Tapos, yung crystal, sharp, no? Sharp and well-defined yung melting point. Ito naman, they have amorphous, they have poorly defined patterns, no? And therefore, cannot be, if that's the case, they cannot be used to identify these amorphous solids. No? Now, a glass is an amorphous translucent solid. Okay. Now, I have here a remark. Almost any substance can solidify in amorphous form if the liquid phase is cooled rapidly enough. So, pag mabilis ang cooling, halos lahat, no? Halos lahat, meron ding hindi, halos lahat ng substance can solidify in amorphous form. Ano nga yung amorphous? Yung walang order. Okay? Kailan yun? Pag mabilis yung cooling. Now, some solids, however, are intrinsically amorphous. No? Kahit hindi na mag-effect ng cooling. Why? Because either their components cannot fit together well enough, to form a stable crystalline lattice, or they contain impurities that disrupt the lattice. Okay, for example, although the chemical composition, I have figures or pictures later on. Although the chemical composition and the basic structural units of a quartz crystal and a quartz glass are the same, pareho lang silang silicon dioxide, no? So merong quartz crystal, merong silicon dioxide crystal, meron din silicon dioxide quartz glass. And a glass is an amorphous solid, di ba? Okay? Both are SiO2 and both consist of linked SiO4 tetrahedra, no? The arrangement of the atoms in space are not the same, no? Now, crystalline quartz contain a highly ordered arrangement of silicon and oxygen atoms, but in quartz glass, the atoms are arranged almost randomly. Alam naman natin yun, ano? Yung crystals, highly ordered. Yung amorphous glass in this particular example are arranged randomly. Now, when molten SiO2 is cooled rapidly, it forms quartz glass, and glass is amorphous. Whereas the large perfect quartz crystals sold in mineral shops have had cooling times of thousands of years. Dahil minimina yun, ano, thousands of years yung nilaan para lumamig, kaya naging crystals. No? In contrast, aluminum crystallizes much more rapidly. No? Yung SiO2 yung kanina. No? In contrast naman, aluminum crystallizes much more rapidly. No? And amorphous aluminum forms only when the liquid is cooled at the extraordinary rate of 4 times 10 to the 13 Kelvin per second. Super bagal. To form amorphous aluminum. So, ang aluminum crystals, mas marami sa nature. So, ito yung itsura ng SiO2. Tetrahedra. No? So, apat etong atoms na to, tapos nandun sa gitna yung silicon. Okay. Ito naman, kita nyo naman. Sana ma-imagine nyo yung orientation sa space, no? Tetrahedra siya, no? Hindi siya nasa plane, ha? Now, in an amorphous solid, the local environment, including both the distances to neighboring units and the number of neighbors, varies throughout the material. Very unlike crystals na fixed, diba? And therefore, because of this, different amounts of thermal energy are needed to overcome these different interactions. Thus, amorphous solids tend to soften slowly over a wide temperature range rather than having a well-defined melting point like a crystalline solid. If an amorphous solid is maintained at a temperature just below its melting point for long periods of time, the components, molecules, atoms, or ions can gradually rearrange into a more highly ordered crystalline form. Okay? Ito, sinabi na natin kanina, crystals have sharp, well-defined melting points. Amorphous solids do not have. Okay? Now, because a crystalline solid consists of repeating patterns of its components in 3 dimensions, and we call that a crystal lattice, the entire crystal can be represented by drawing the structure of the smallest identical units. Okay? The basic repeating unit is called a unit cell. So pag in-stack together mo yung basic repeating unit or unit cell, we form the crystal. Okay? So ito yung smallest unit cell, smallest portion rather of the crystal lattice, and we call it the unit cell. So pag ni-stack mo together, ito yung magiging itsura ng crystal lattice. No? You get one, that's a unit cell. Okay? So a crystal can be thought of as the same unit cell repeated over and over in 3 dimensions. Okay? So ano yung makikita natin sa unit cell, no? So meron tayong mga sides na to, ang tawag dyan ay edges, no? Pero ito yung mga axes, no? So you have Y, you have Z, and then X. So itong mga to, yan ang mga edges, no? Ayan. Tapos, yung mga plane, so yung mga plane na yan, ang tawag doon ay faces. No? So, this one has how many faces? 6, no? Kasi 6 sides yan. So, has 6. Itong nasa taas, nasa ibaba, nasa likod, itong nasa harap, tapos nasa kanan, saka nasa kaliwa. And then we also have the angle of intersection, ano? Between the faces. So ito meron tayong alpha, beta, and gamma. So tatlo yung angle. Okay. So unit cells in 2 dimension. 2 dimension na lang ito, no? So ano ngayon ang pwedeng gamitin? How do we illustrate the possible choices of the unit cell, no? Because the unit cells differ in their relative locations or orientations within the lattice. Okay? But they are all valid choices because what? Why? Repeating them in any direction fills the overall patterns of that. So the first three ABC can be used, no, to represent unit cells in 2 dimensions, whereas the fourth one cannot. This is not a valid representation. Why? May mga empty spaces. Ayan. So hindi ito pwede, no? So the triangle is not a valid unit cell because repeating it in space fills only half of the space in the pattern. So, ang valid representation are these three, okay? If we will represent unit cells in 2 dimensions. Now, let's discuss a bit more about the unit cell. There are 7 fundamentally different kinds of unit cells, no? They differ in the relative lengths of the edges and the angles between them. Now, each unit cell, as I mentioned earlier, has 6 sides, and each side is a parallelogram, no? So, yung sides na yun, yung tinatawag nating face, okay? The focus primarily is on the cubic unit cells in which all sides have the same length and all the angles are 90 degrees. So, pag pare-pareho ng length yung mga sides at lahat ng angles ay 90 degrees, cubic unit cell yun. Okay? So, ganito yung itsura, no? Ito yung edges, ito yung angles, no? Pag yung mga edges, pantay-pantay, ayan, yung mga lengths, pantay-pantay. Tapos yung angle, no? Intersecting angles, which we call alpha, beta, and gamma are all 90. And the edges are ABC are equal. Then we have a cubic, no? A cubic unit cell. If the two sides are equal, but the third side is different, and the angles of intersection are all 90, then we have a tetragonal unit cell. If all the sides have different measure, so iba-iba, but the angles are the same, then we have orthorhombic. So itong tatlo na to, cubic, tetragonal, and orthorhombic, all angles are 90 degrees. Okay? Then we have a monoclinic, like orthorhombic, that the edges are not equal, but two angles are equal, no? Alpha and gamma are both 90 degrees. Beta is not equal to 90 degrees. So that's a monoclinic unit cell. Then we have a hexagonal where two edges or two sides are equal. The third side is different. The two angles alpha and beta are 90 degrees, but gamma is 120 degrees. So that's a hexagonal unit cell. And then we have a rhombohedral where the three sides or edges are of the same measure. The two angles alpha, beta are the same, but gamma, the third angle, is not equal to 90 degrees. Okay? So, in rhombohedral, the three angles alpha, beta, and gamma are of the same measure, pare-pareho sila, pero less than 90 degrees. So, all acute angles. Sa triclinic naman, all sides are of different measure, iba-iba ang measurement. Tapos, lahat ng angles of intersection, hindi rin pare-pareho and they are not equal to 90 degrees. So, that's a triclinic. Okay? So, ito naman, cubic structure. So, if the cubic unit cell consists of 8 component atoms, molecules or ions located at the center, no? At the corners rather, at the corners of the cube. Then we have a simple cubic, no? So bawat corner meron, so 1, 2, 3, 4, 5, 6, 7, 8. We call this a simple cubic. Okay? Pag simple cubic tapos nilagyan mo ng isang atom sa gitna, body-centered cubic. Okay? Pag yung simple cubic, nilagyan mo ng mga atom sa faces, no? Ilan yung faces? 6 yun, di ba? You call that a face-centered cubic. Okay? Now, how many atoms are there in a simple cubic, body-centered cubic, and face-centered cubic? So, ito yung simple cubic, yung may 8 atoms, no? Pero, ang amount lang naman ay, 1/4, di ba? Okay. 1/8 rather, 1/8. Okay, 1/8 kasi 8 corners yan eh. Therefore, pag pinagsama-sama mo yan, we only have 1 atom. So, a simple cubic contains only 1 atom. A body-centered cubic, so yung simple cubic, mayroong 1 atom, tapos may isang atom sa gitna ang body-centered. So, obviously, a body-centered cubic has 2 atoms. Okay? While a face-centered cubic has how many? So, ang face-centered cubic ay simple cubic, no? So, meron siyang isa, no? Tapos, lahat ng faces, meron kalahati. We have 6 faces. So, 1/2 times 6, so that's 3. So, 1 atom, because of the corners, plus 3 atoms because of the faces. Then, all in all, there are 4 atoms in a face-centered cubic. Okay? Ulit, sa simple cubic, 1. Sa body-centered, 2. Sa face-centered cubic, 4. Okay? So that's all for now. Thank you for listening. I hope you have an initial understanding of the crystalline structure. Okay? I'll stop sharing now, and you stay safe and you stay healthy. The next video will be about determining the number of atoms, no, in a particular element, okay, or crystal. Okay, so I'll see you in our next video. You stay safe and you stay healthy, class. Bye for now.